NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial, where we'll learn how to solve fractional equations. We'll follow a clear step-by-step approach to solve two examples. Let's start with our first example. We need to solve the equation 1 minus 5 over x plus 2 divided by x over x plus 2 equals 2. Let's solve this step by step. First, we'll multiply both sides of the equation by the denominator of the left side, which is x over x plus 2. Now, let's simplify the right side. We have 2 times x over x plus 2, which equals 2x over x plus 2. To eliminate the fraction in the left side, we'll multiply both sides by x plus 2. This will clear the denominators and simplify our equation. Next, we'll simplify the numerator on the left side. X plus 2 minus 5 equals x minus 3. Since both sides of the equation have the same denominator, we can equate the numerators. So, x minus 3 equals 2x. Now, we'll solve for x by subtracting x from both sides. This gives us negative 3 equals x. Therefore, our solution is x equals negative 3. Let's move to our second example. We need to solve the equation 2x plus 4 divided by x plus 2 equals 1. For this equation, we'll multiply both sides by the denominator x plus 2. We simplify the right side. 1 times x plus 2 equals x plus 2. Now, we'll subtract x from both sides to gather the terms with x on one side. Finally, we'll subtract 4 from both sides to solve for x. Let's check if our solution, x equals negative 2, is valid. If we substitute this value back into the original equation, we get 2 times negative 2 plus 4 divided by negative 2 plus 2. This gives negative 4 plus 4 divided by 0, which is undefined. So, x equals negative 2 is not a valid solution because it makes the denominator 0. Therefore, this equation has no solution, since x equals negative 2 makes the denominator 0, which leads to undefined expression. Let's summarize what we've learned about solving fractional equations. The equation we're going to solve is 5x over 3x minus 3 plus 6 over x plus 2 equals 5 over 3. Let's start by rewriting our equation to make it clearer. In the first term, we can factor out a 3 from the denominator, giving us 5x over 3 times x minus 1. This form will be easier to work with as we proceed. Now, we'll solve this step by step following a specific algorithm. The first step is to multiply both sides of the equation by the common denominator of all fractions. This will eliminate all fractions from our equation. The denominators in our equation are 3 times x minus 1, x plus 2, and 3. We need to find the least common denominator, which would be 3 times x minus 1 times x plus 2. Let's multiply every term in our equation by the common denominator. When we do this, we get 3 times x minus 1 times x plus 2 times the left side equals 3 times x minus 1 times x plus 2 times the right side. Now, let's distribute this common denominator to each term in our equation. For the first term, the common denominator divided by 3 times x minus 1 gives us x plus 2. For the second term, the common denominator divided by x plus 2 gives us 3 times x minus 1. And for the right side, the common denominator divided by 3 gives us x minus 1 times x plus 2. Let's expand these expressions. First, 5x times x plus 2 equals 5x squared plus 10x. Next, 6 times 3 times x minus 1 equals 18x minus 18. Finally, 5 times x minus 1 times x plus 2 equals 5 times x squared plus x minus 2, which equals 5x squared plus 5x minus 10. Now, we can combine like terms on the left side. 5x squared plus 10, x plus 18x minus 18 equals 5x squared plus 5x minus 10. Simplifying further, we get 5x squared plus 28x minus 18 equals 5x squared plus 5x minus 10. Let's move all terms to one side by subtracting 5x squared plus 5x minus 10 from both sides. This gives us 5x squared plus 28x minus 18 minus 5x squared minus 5x plus 10 equals 0. Simplifying, we get 23x minus 8 equals 0. Finally, we can solve for x. 23x equals 8. So x equals 8 divided by 23. Welcome to this mathematics tutorial. Today, we'll solve a fractional equation step by step. Let's look at our equation. To solve this equation, we'll start by clearing the fractions. We notice both fractions have the same denominator, y minus 1. So our first step is to multiply both sides of the equation by y minus 1. This will help us eliminate the denominators. Now, let's distribute the y minus 1 on the right side of the equation. We multiply y minus 1 by 2, and we also multiply y minus 1 by 7 over y minus 1. Let's simplify both sides of our equation. On the left side, y minus 1 cancels out with the denominator, leaving us with just 3y plus 4. On the right side, we have 2 times y minus 1, which is 2y minus 2, and 7 times y minus 1 over y minus 1 simplifies to just 7, since the numerator and denominator cancel out. Now, let's expand 2 times y minus 1 on the right side. We get 2y minus 2 plus 7, which equals 2y plus 5. Now, let's bring all terms with y to the left side and all constant terms to the right side. We'll subtract 2y from both sides and subtract 4 from both sides. Now, let's simplify both sides of the equation. 3y minus 2, y gives us y, and 5 minus 4 gives us 1. So we have y equals 1. Let's verify our answer by substituting y equals 1 back into the original equation. If we put y equals 1 into the original equation, we need to be careful because y equals 1 makes the denominator y minus 1 equal to 0, which means the fractions are undefined. So y equals 1 cannot be a solution to our equation. Therefore, we conclude that the original equation has no solution. The algebraic manipulation led us to y equals 1, but this value makes the denominator has no solution. The algebraic manipulation led us to y equals 1, but this value makes the denominators in the original equation equal to 0, which is not allowed in the domain of the equation. Let's take a look at our example. We need to solve the equation x over x minus 3 equals x plus 1 over x minus 4. To solve this rational equation, we'll need to eliminate the fractions by multiplying both sides by the common denominator. Let's solve this step by step. Step 1. We multiply both sides of the equation by the product of the denominators, which is x minus 3 times x minus 4. This gives us x times x minus 4 equals x plus 1 times x minus 3. Step 2. Now we'll expand the products on both sides of the equation. On the left side, x times x minus 4 gives us x squared minus 4x. On the right side, x plus 1 times x minus 3 expands to x squared minus 3x plus x minus 3, which simplifies to x squared minus 2x minus 3. Step 3. We'll move all terms to one side to form a standard equation. Let's subtract x squared from both sides, and then we'll add 4x and 3 to both sides. This gives us negative 4x plus x squared minus x squared plus 2x plus 3 equals 0, which simplifies to negative 4x plus 2x plus 3 equals 0, or negative 2x plus 3 equals 0. Step 4. Now we can solve for x. Let's subtract 3 from both sides to get negative 2x equals negative 3. Then we divide both sides by negative 2 to get x equals 3 divided by 2. Step 5. Let's check our solution by substituting x equals 3 over 2 into the original equation. For the left side, we get 3 over 2 divided by 3 over 2 minus 3. Simplifying, we get 3 over 2 divided by negative 3 over 2, which equals negative 1. For the right side, we substitute into x plus 1 over x minus 4. We get 3 over 2 plus 1 over 3 over 2 minus 4, which simplifies to 5 over 2 over negative 5 over 2, which also equals negative 1. Since both sides equal negative 1, our solution x equals 3 over 2 is verified. Let's summarize the steps we followed to solve this rational equation. First, we multiplied both sides by the common denominator x minus 3, x minus 4. Next, we expanded the products on both sides. Then we collected like terms and moved everything to one side. We solve for x to get x equals 3 over 2. Finally, we verified our solution by substituting it back into the original equation. This approach works for solving many types of rational equations. Remember to always check your solutions in the original equation to make sure they don't create zero denominators. The equation we'll be working with is the fraction 3x minus 7 over 4x plus 2 minus the fraction 3x minus 14 over 4x minus 13 equals 0. Let's follow the algorithm shown in our reference. The first step is to create a common denominator by multiplying the numerator and denominator of each fraction by the denominator of the other fraction. This gives us the expression shown here. A fraction equals 0 only if its numerator equals 0, while the denominator is not 0. Therefore, we can say that the numerator equals 0. Let's expand this expression. Let's use the distributive property to expand the first product. We have 3x minus 7 multiplied by 4x minus 13. When we multiply these binomials, we get 12x squared minus 39, x minus 28x plus 91, which we can simplify to 12x squared minus 60, x minus 28x plus 91, which we can simplify to 12x squared minus 67x plus 91. Now, let's expand the second product. 3x minus 14 multiplied by 4x plus 2. We get 12x squared plus 6x minus 56x minus 28, which simplifies to 12x squared minus 50x minus 28. Next, we'll combine like terms. We have 12x squared minus 67x plus 91, and we're subtracting 12x squared minus 50x minus 28. When we distribute the negative sign into the second parentheses, we get 12x squared minus 67x plus 91 minus 12x squared plus 50x plus 28. Now we can combine like terms. When we combine like terms, the 12x squared terms cancel each other out. We get negative 67x plus 50x plus 91 plus 28, which simplifies to negative 17x plus. When we combine like terms, the 12x squared terms cancel each other out. We get negative 67x plus 50x plus 91 plus 28, which simplifies to negative 17x plus 119 equals 0. Now, let's isolate the variable x. First, we'll subtract 119 from both sides. We get negative 17x equals negative 119. Next, let's begin with our example. We need to solve the following equation. X minus 1 over x minus 2 plus x over x plus 2 minus x squared plus 2x minus 4 over x squared minus 4 equals 0. The first step in solving this equation is to find a common denominator for all the fractions. Let's note that x squared minus 4 can be factored as x minus 2 times x plus 2. This means we can use x squared minus 4 as our common denominator. So our first step is to combine these fractions by getting a common denominator, and then simplifying the numerator. Now we need to expand the numerator by removing the parentheses. We'll use the distributive property to multiply the terms. Let's calculate each part. X plus 2 times x minus 1 equals x squared plus x minus 2. X times x minus 2 equals x squared minus 2x. And we subtract x squared plus 2x minus 4. So our equation now looks like this. Let's expand the expressions in our equation. The first term, x plus 2, x minus 1, becomes x squared minus x plus 2x minus 2, which simplifies to x squared plus x minus 2. The second term, x minus 2, becomes x squared minus 2x. And we're subtracting the third term, x squared plus 2x minus 4. So our equation becomes. Now, let's simplify the expression by combining like terms. We have x squared plus x minus 2 plus x squared minus 2x minus x squared minus 2x plus 4. Combining the x squared terms, we have plus x squared minus x squared, which gives us x squared. For the x terms, we have plus x minus 2x, which gives us negative 3x. And for the constant terms, we have minus 2 plus 4, which gives us plus 2. So our equation simplifies to x squared minus 3x plus 2 equals 0. The next step is to factor this quadratic equation. We need to find two numbers that multiply to give 2 and add up to negative 3. Those numbers are negative 1 and negative 2. So x squared minus 3x plus 2 can be factored as x minus 2, x minus 1. Our equation is now x minus 2, x minus 1 equals 0. Now we can use the zero product property to find our solutions. The zero product property tells us that if a product equals 0, at least one of the factors must be 0. So we have two possibilities. Either x minus 2 equals 0, which means x equals 2, or x minus 1 equals 0, which means x equals 1. Therefore, the solutions to our equation are x equals 1 and x equals 2. However, we need to check our solutions for domain restrictions. Remember, in our original equation, we have denominators of x minus 2, x plus 2, and x squared minus 4. For x equals 1, let's check if it causes any denominators to become 0. 1 minus 2 equals negative 1, which is not 0. 1 plus 2 equals 3, which is not 0. 1 squared minus 4 equals negative 3, which is not 0. So x equals 1 is a valid solution. For x equals 2, let's check. 2 minus 2 equals 0, which makes the first denominator 0. So x equals 2 is not a valid solution, as it causes division by 0. Therefore, the only solution to our equation is x equals 1. Let's summarize what we've learned. To solve algebraic fraction equations, first, find a common denominator and combine all fractions. Next, simplify the numerator by expanding all expressions and combining like terms. Then, solve the resulting equation, usually by factoring or using the quadratic formula. Finally, always check your solutions to ensure they don't make any denominators 0. In this example, we found that only x equals 1 is a valid solution, as x equals 2 would cause division by 0 in our original equation. Let's look at our example. Our problem is to solve the equation 5 over x minus 2 minus 3 over 2x plus 4 equals 3x minus 1 over x squared minus 4. Let's start by moving all terms to the left side of the equation, making the right side equal to 0. We'll subtract the term 3x minus 1 over x squared minus 4 from both sides. This gives us 5 over x minus 2 minus 3 over 2x plus 4 minus 3x minus 1 over x squared minus 4 equals 0. Now, before we can combine these fractions, we need to find a common denominator. Notice that 2x plus 4 can be factored as 2 times x plus 2, and x squared minus 4 can be factored as x minus 2 times x plus 2. So our common denominator will be 2 times x minus 2 times x plus 2. Now, let's convert each fraction to have this common denominator. For the first fraction, we multiply both numerator and denominator by 2 times x plus 2. For the second fraction, we multiply both numerator and denominator by x minus 2. And the third fraction already has the denominator we want, but we need to multiply by 2. This gives us 2 times x plus 2 times 5, all over 2 times x minus 2 times x plus 2, minus 3 times x minus 2 all over 2 times x minus 2 times x plus 2, minus 2 times 3x minus 1 all over 2 times x minus 2 times x plus 2 equals 0. Next, let's expand the expressions in the numerator. First, 2 times x plus 2 times 5 equals 10x plus 20. Then, 3 times x minus 2 equals 3x minus 6. Finally, 2 times 3x minus 1 equals 6x minus 2. So our equation becomes 10x plus 20 minus 3x plus 6 minus 6x plus 2 all over 2 times x minus 2 times x plus 2 equals 0. Now, let's simplify the numerator by combining like terms. We have 10x minus 3x minus 6x, which gives us x, and 20 plus 6 plus 2, which gives us 28. So our equation becomes x plus 28 all over 2 times x minus 2 times x plus 2 equals 0. Now, for a fraction to equal 0, its numerator must be 0, assuming the denominator is not 0. So we set x plus 28 equal to 0. Solving for x, we get x equals negative 28. We need to check if this value is in our domain. Our original expressions had denominators of x minus 2, 2x plus 4, and x squared minus 4. We need to make sure x is not equal to 2 or negative 2. Since negative 28 is not equal to 2 or negative 2, our answer is valid. Therefore, the solution to our equation is x equals negative 28. Let's verify this by substituting back into the original equation. We would need to check that 5 over negative 28 minus 2 minus 3 over 2 times negative 28 plus 4 equals 3 times negative 28 minus 1 over negative 28 squared minus 4. I'll leave that verification as an exercise. Let's summarize what we did to solve this rational equation. First, we moved all terms to one side to get 0 on the right side. Then we rewrote all terms over the common denominator 2 times x minus 2 times x plus 2. We expanded and combined the numerator to get x plus 28. We set x plus 28 equal to 0 and solved to get x equals negative 28. Finally, we checked that this value is not equal to 2 or negative 2, confirming it's a valid solution. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.